What's up, everybody? Messing with my TIG torch here. Welcome to Iron Vlog number 137. This is my journey to become Iron Man. Today, we're talking about TIG welding. TIG welding aluminum in particular. If you're watching this because you found it and you're trying to figure this out, this is just my experience. This is experience of someone who knows pretty much nothing about TIG welding aluminum, just so you know. So this is just me just thinking out loud about some of the shit I'm working on and trying to figure out how I'm gonna weld this together. So, let's see here. I have just tons of aluminum that look like this. They look awful, by the way. Like, if you look in some spots, like this weld right here looks real nice. That was a really fast beaded weld that looked really good. This one right here got too hot. You know, I've been doing all these things, and one thing I've gotten pretty good at is just running a bead. Like I said, this bead looked pretty good. This one got too hot. The metal was a little too saturated with heat, and I hit it a little too hot, so that one didn't run very well. I think that's what happened. This one like beaded up perfectly. It's a nice small bead, and then there's fucking burns and shit all over this where whatever happened, something oxidized, which means I just fucked something up. I think some of it burned, and I think a couple of these times I plunged my TIG tungsten into the aluminum. That happens more than I care to admit, especially on these specific type of joints that I'm having trouble with. But if you don't know, this is what TIG tungsten looks like. I can't get it to focus on that here. Well, okay, I can't get it to focus, but this is just a piece of tungsten, and then the tip is really, really sharp. If you look at videos of how to grind this stuff, you'll see it, but this is a really sharp tip. What happens, for starters, welding anything other than aluminum is easier because this tip stays sharp. When you weld aluminum, there's an oxide layer that builds up on this, and you have to jump through the oxide layer, and the only way to do that is to jump your arc from your workpiece to your tungsten, to break the oxide, then you come back in the other way. So you have what's called AC balance, and you set the balance. And what happens is the heat goes the direction the electricity is traveling. So the heat goes into the part if you're traveling from the tungsten to the workpiece, which is how you normally weld. So this thing doesn't get very hot. I mean, it gets red hot, but it doesn't melt. So it stays super sharp, and you have a lot of control over where the arc is going. When you weld aluminum, this thing gets hot and it starts to ball up. And it also just kind of degrades in general. This isn't the tungsten I use. This is a different type of tungsten. It's not made for DC, but the one I have is called a lanthanated tungsten piece, but it turns into a ball, and so it becomes very hard to weld this stuff. So you lose control over your arc, which makes this difficult anyway. And then I'm not very good at doing something called a lap joint or a fillet joint. What a lap joint is if you take this piece right here and you lay it down on here, and then you weld it to the part that it's laying on. That would be a lap joint. And it's essentially and then the type of weld you put down on it is called a fillet weld. And a fillet weld, whenever you have a fillet, it's a radii, so you put a radius on it. So you essentially take your fillet wire. So when you're holding this thing that has a tungsten in it, you take it, you heat it up with a pedal. So there's three things going on at once. There's a pedal you're not even seeing, but I would press the pedal down, and then I get the arc started, and then once I got a pull, I let up on the pedal, and then you fill in this wire here, and you fill it in. That's how you would make that fillet weld, and that's what I'm trying to learn right now. The problem is that when you if this area in here was where we're trying to weld, the problem is getting the electrode really deep in there so that it's actually melting in the corner, which is what you want. You want it melting all the way in there because that's where you want the metal to go to have a complete weld. And in order to do that, it helps to have a sharp electrode. You have to have a really tight arc. So, because what happens if you come up, these two pieces of metal are closer, so the arc jumps in between these two, and it's hard to get the arc to move down into this. And of course that's even harder with aluminum, because when you're working with aluminum you have a balling tungsten. It's literally degrading the more you weld. So the longer you weld, the more it balls. So it can start off sharp, so you can sometimes start off your arcs that way, but then they ball up. So what I'm really trying to figure out is how to do these fillet welds, and I'm not very good at them. And I realize not only am I not good at it in aluminum, I'm also just not very good at it in general. So it's something I need to practice and get better at. So I did a whole bunch of welding, and then the weird thing about welding aluminum is it saturates. It's more sensitive to the heat, so it's easier to overheat stuff. It seems like with aluminum, especially. I mean, you can do this with steel, but I've never melted a hole straight. Well, it's not true. I've only melted a hole straight through steel like a couple of times, but I've done it with aluminum a lot because aluminum just saturates up with heat. And then the crazy thing is, is this thing is super conductive of heat. That's why they make heat sinks out of it. So if you weld over here, the heat right here, except for right around the weld, it's almost as hot like right up here as it is all the way over here, because the heat just runs across this stuff. So if you weld over here and you come over here to weld, now you're changing how you weld, because this has to be welded now at lower amperage because it's saturated with heat. So it's tricky to figure that out too, and you really just kind of, I think you can measure it with thermometers. They do that in some aerospace stuff, but the other thing they do is you can just kind of tell when you're welding what the pool looks like and how much heat is in the part. And then sometimes you can feel the heat coming off it, and you can just tell if it's starting to become saturated with heat a little bit. Like I said, I'm not that great at this, but you can see I've messed around with this. I tried to do 2 seams of lap joints. They don't look that great. I actually started to sort of kind of get a little bit of a lap joint going here, but you can see the problem I'm having is they're really big and spread out, which is, again, I don't know how to do it, but I'm having trouble with it because of how rounded the tungsten is getting. And then again, I don't really know what I'm doing here. It's not like I did this professionally or anything. There's a couple of them in here. Actually, I think this one might be Tim's. Tim started to figure it out. I think he's done more of these type of joints than me. I haven't really done a whole lot of these welds. Now that I'm thinking about it, I'm not sure I ever really was very good at them. I got kind of okay with them at the stick welder, because essentially this table is nothing but those, and they look decent. They're nothing but fillet joints. But I actually missed probably like 4 of them. I'd actually need to go back and retouch up on this, because I actually missed a bunch when I did it. So that just goes to show you I'm not that great at doing these joints. So I started to get, this one actually looks pretty good right here. This one's nice and small. This was me this morning. I did that one. Tim did one on steel that was the best one we had the other day. And you can tell his right here. If you look at it kind of closely there, you can see that the fillet in there is a lot smaller. And so this one right in there, you can see that it doesn't cut into that corner at all. And if you look at that compared to this one, which is one of my cleanest aluminum ones, you can see that edge doesn't quite line up with the edge over here. So this edge right here doesn't line up with this edge over here. That means I was blowing out and burning out that aluminum. I mean, this thing isn't coming apart, but it's not a very pretty weld. And there's also probably too much heat going into the metal, and it's probably going to cause some warpage and stuff. It's like you want to make your welds kind of like this, where they're taking up the least amount of room possible, and so they're just enough weld there to do its job, but not more than that, so you're not blowing out the part and putting too much heat into it and stuff like that. So this is what I got to be able to do essentially on aluminum in order to build my suit. Alright guys, so I've been working on that welding stuff, and I kind of want to show you what was going on in my head and how I'm trying to figure this shit out. Welding's difficult, but I'll get there. I like welding. It's something that I'm addicted to, and Tim also likes welding. And when we're over there welding, and it's hard work. It's hot. It's, you know, it hurts your eyes a little bit. It's not necessarily comfortable to do. It takes it out of you. Tim got tired. I mean, he's a lot older than me, but he was getting tired too. We were both tired, and we were both essentially fighting over, like, let me use a TIG stick now. No, let me use it now. So we were like going back and forth, like, no, I want to do it. So we both love welding, and so I'm gonna get better at it as I work, for sure. But it's coming along. We're getting there. I'm really excited to be able to do it and do it awesome. It's gonna be fun. I have 2 projects I'm gonna work on that'll help me learn how to weld. I learn better when I just start building shit like this video than I do tabbing. I mean, this is important for me, and then I take what I'm starting to learn and I get good at it when I'm actually trying to weld something. There's something about being like, okay, I know this weld has to work, that makes me learn it a little bit better. So I just learn a little bit better that way when I'm like, okay, fuck it, let's just actually build something. I mean, this is important too, don't get me wrong, it's important to practice your skills too. And I think what I'm gonna do is when I buy a bunch of scrap material, I'm gonna make a whole bunch of, these are called coupons. You can buy them, but I'm gonna build them because they're expensive to buy. But I'm gonna build a whole bunch of those out of bar stock, and then I'll have them in like a bucket, and then every time I weld, I'll start off with some practice, and then I'll start welding. But I'm gonna weld an aluminum cart, and then I'm gonna weld a welding cart, because if you can't tell, this shit is all kinds of messy right now, and I really need to put this all in one spot because this is too chaotic for sure. So I need to do that before I make the suit, and it'll be good practice. I'm gonna make that out of aluminum, and then I'm either gonna make it out of aluminum or steel, but I'm gonna make an English wheel, and that's gonna help me build the skin for the suit. Anyway, guys, I've been working on the forearm. It's actually gonna go pretty well. I think I've got it figured out how I'm gonna do it, which I didn't know how I was going to do it before. I think I know how I'm going to do it this time. But I don't really have much to show you on that because it's still in the very early stages. It was more of a gestation, brainstorming kind of day. So come back tomorrow, I'll probably have some work going on that. Anyway, guys, that's it from me today, and come back tomorrow. I love you guys. If you're seeing this for the first time because you're interested in me rambling about TIG welding on aluminum, smash the subscribe button. There's a lot of cool welding to come. See you guys later. I love you.